Hello everyone, we are here to talk about steps for performing hypothesis testing. So, what is hypothesis testing? Hypothesis testing refers to making a predictive statement called hypothesis about a population, setting the criteria for decision, selecting the level of significance or confidence, calculating a sample statistic, using the sample statistic to evaluate the hypothesis and making a decision about our hypothesis. How likely is that our hypothesis is correct? To test the validity of our assumptions, we determine the difference between hypothesized parameter value and sample value. We'll explain each and every step in detail further in this video. So, what are the criteria for setting a hypothesis? The hypothesis which we are setting should be clear and precise and should be limited in scope. That means that it should focus on a very specific thing of our population or a specific behavior to be shown by our population, and it should state relationship between our variables, and it should remain consistent with most known facts. Importantly, it should be testable. By testable, I mean that it should be statistically testable. So, few examples of hypothesis can be: there is a marketer in Amazon who believes that placing an order now button on the left side of the page could get them more customers. So, this is an example of hypothesis. But to calculate this, we have to have a particular set of customers who have already experienced the order now button to be on the left, and we have to see their behavior in terms of the behavior of the normal population, and then we have to see the statistical difference between the behavior of both the samples. So there are two major types of hypothesis. One is null hypothesis. Null hypothesis, it's an assumption of we hold as true unless we have sufficient statistical evidence to conclude otherwise. So an example for null hypothesis: generally we assume null hypothesis as the mean of the sample will be equal to the mean of population. That's the most general form of null hypothesis given, and null hypothesis is denoted by H naught. Alternative hypothesis is a negation of null hypothesis and is denoted by HA. If null hypothesis is given as H naught, mu is greater than mu naught, and then alternative hypothesis can be given as mu is less than mu naught. Suppose in the case we have a null hypothesis that performing a meditation doesn't make any effect on the patient blood pressure, or it will increase the patient's blood pressure. So in that case, our alternative hypothesis would be that performing a meditation would decrease the patient's blood pressure. That means the mean of the sample of population who performed meditation, the mean blood pressure for those would be lower than the mean blood pressure of the normal population. So, criteria for decision. To set the criteria for decision, we state the level of significance for a test. So, the level of significance is defined as the probability of a false rejection of the null hypothesis. That means that if probability of getting a sample mean of x value is 2%, then, and if I have assumed my level of significance as 5%, then I would state that my null hypothesis is wrong and I would accept my alternative hypothesis. The level of significance is denoted by alpha and confidence interval is denoted by 1 minus alpha. So this is in this graph we are trying to explain an example for level of significance in case of two-tailed test. So basically two-tailed test is something in which we don't know in what way our new sample will behave, whether the mean of our new sample will increase from the norm on the mean of our population or it will decrease from the mean of our population. So depending on this, we decide whether to reject the null hypothesis or to accept. So the area which is shaded in gray over here is considered as rejection region. It means that if there is a sample mean lying in this area, then we will reject our null hypothesis. And the area which is colored in, which is not colored, which is in white color, is considered as non-rejection region. That means that if our sample mean is in that particular white area, then we will accept our null hypothesis. So there's a norm we have that mean plus 1 standard deviation and mean minus 1 standard deviation. This distribution constitutes 68% of the population, and mean plus 2 standard deviation and mean minus 2 standard deviation constitutes 95% of the population. So if you are having a level of significance as 5, then you should be having a value greater than mean plus 2 standard deviations to reject your null hypothesis. So in different types of cases, we have to use different types of statistical tests to calculate the sample statistics. So if the population is normal, then we will check whether we know the standard deviation about the population or not. If we don't know the standard deviation, then we'll use a t-test statistic. If we know the standard deviation, then we will use z-test statistic. And if the population is not normal and the sample size is greater than or equal to 30, we'll use z-test statistic. And if the sample size is not greater than or equal to 30, we'll use a non-parametric test. So the formula for z value is given as x bar minus mu divided by standard deviation of the population divided by square root of n. So x bar is the mean of the sample on which we are performing our hypothesis. Mu is the sample mean taken from the population, or we can say it's a population mean. Sigma is the standard deviation of the population, and n is the number of samples on which we are performing our hypothesis. So using this formula we calculate z-score, and using z-score we calculate the probability of that to happen. So the probability of x bar to occur on this population distribution or sample distribution is calculated from z-score. So for calculating the probability we use z-table, So in Z table on the y-axis, you have to refer the Z score till first decimal position, and on the x-axis you have to refer the Z score the second decimal position of Z score, and using a combination of both we'll get a probability value which is also known as p value, which is the probability of that event occurring in that sample distribution. And for t-test, there's a similar kind of table called t-table. In that, we use degree of freedom, which is basically n minus 1. That means sample size minus 1 is defined as degree of freedom, and the level of significance we have set. So if the level of significance is 5%, then in x-axis we will match it to the number 0.05, and degree of and number of samples in this is 23, then we'll match it 22 on y-axis and 0.05 on x-axis to find the t value, on which we'll get a probability of 5% on these number of samples. If our t value is greater than that value or less than that value, depending on that we can take a call whether to reject our null hypothesis or to accept our null hypothesis. So the decision for the hypothesis is calculated using the sample statistic. So if the probability we are getting from Z test or t test is greater than the level of significance we have defined, lies within the level of significance we have defined, then we will accept our null hypothesis, accept our alternative hypothesis, and otherwise we will reject our alternative hypothesis. So performing these kind of statistical tests, there can be few errors which can occur. So if we reject our null hypothesis, and but the actual fact was that the null hypothesis was true on the whole set of population, then that error is known as type 1 error. And if we accept our null hypothesis, but on the whole population alternative hypothesis was held to be true, then this is known as type 2 error. So this was all from my side about hypothesis testing. Hope it was clear for all of you. Please reach out to me in the comment section to discuss about your doubts or questions if you have any. Also, you can give me your feedback on how can I improve my tutorial sessions to make it more clear and precise for you guys. Thank you for seeing the video. Hope you liked it. Cheers.